Yeah.
How's the Bay Area?
Well, my school's really bad, but most of them. During volleyball. Yeah, most of the time. Mine was a lot worse. Like, I was freezing in my bro, it's so loud. It's
Okay, here we go.
God bless you.
Okay. What is the state of motion of this marker? Zero, right? At rest. What is its inertia want? What does its inertia wants to do?
Hold on. Stay.
Wants to stay at rest. Right? Okay, so check this out. Yeah. Okay. Did it stay at rest? No. Didn't. Why not? Gravity is like boom. But which way, in which direction was gravity acting? Downward. More general, vertical. How did the marker move horizontally? It didn't. Why not? It went vertical, but why didn't it move horizontally? There was no forces acting on it in the horizontal direction. So it did exactly what inertia wanted to do horizontally. Vertically, it was not happy. It was like, ah! Because of gravity. It's like, no, get down here. But horizontally, it's like, dude, I'm just chilling. And is able to go into the flask. Okay, does that make sense? Okay, so in the vertical direction, it experienced acceleration because of the force of gravity. Didn't do what inertia wanted to do, but horizontally, it did. It stayed at rest and wanted to. Okay, so big idea. Forces that act on an object vertically only affect the object's vertical motion and do not affect the object's horizontal motion. Okay? Horizontal motion and forces are independent of vertical motion and forces. Okay? They are independent of each other. Good with that? Okay. Because they're independent, we need to separate out their variables, making a distinction between how something is moving horizontally and how something is moving vertically. Okay? It's a big idea that will carry it through this chapter and in the next. Okay? Horizontal motion is independent of vertical motion. Okay? I guess let me do a little foreshadowing here. Do you remember when we were talking about the bear and the tourist?
Yeah.
And we had a list of variables that are independent of each other. We had a list of variables for the bear, we had a list of variables for the tourist. We had an equation for the bear, we had an equation for the tourist. We have the same flavor. They're independent of each other. Okay? All right, so question. If you threw a ball off horizontally and dropped one from the same height at the same time, which one's going to hit the ground first? a guess? What do you think's going to happen here? This device is going to drop this at the same time it shoots this. Okay. Good with that? Quick disclaimer. The shooting part is anticlimactic. It's more of like a nudge. Okay, but the idea is the same. Okay? It's going to be hard to see from your vantage point which hits the ground first, but I want you to use your ears. Okay? The one dropped is plastic, the one shot is metal. Okay? Ready? 3, 2, 1. What'd you hear? Same time. Okay? They hit the ground at the same time. Now, that's true. We just observed that. Now we need to figure out why. Okay? Take a stab at that question. Thumbs up when you have a guess. Tell your neighbor and tell them why. Correct answer is C. What? Both are 0, but the one you threw is moving. Which way was it moving, though? Horizontally. How fast was it moving vertically? It wasn't. Okay? That distinction between how something's moving horizontally and how it's moving vertically, that is a really, like how your brain is like working right now to make that distinction is a really important brain muscle to exercise for this unit. How is something moving horizontally? How is it moving vertically? Horizontally, it is absolutely moving, but vertically, it's not at all. Because it's only moving horizontally. Vertically, it was at rest. You okay with that? Have a conversation. The correct answer is. Okay. They have in the vertical direction. Are you okay with initial vertical velocity? See how I'm labeling that? Okay, subscript y is equal to 0. We established that from the previous question. What is their vertical acceleration? Okay, both are in free fall. Both fell the same height. I'm going to use delta y instead of delta x for vertical. Okay. Therefore, their final vertical velocity is going to be the same. Okay. Here's big picture. Or not big picture. Like full story. If you did not have depth perception and this ball was shot at you horizontally and this ball was dropped from the same height at the same time, you could not tell a difference between these two balls. They would look identical. Does that make sense? Their vertical motions would be identical. The same. Okay? Because horizontal motion is independent of vertical. Vertical is independent of horizontal. I don't care how fast that's going. Horizontally. How are we doing with that? Next question. Thumbs up and have a guess. Talk to your neighbor. Tell them why.
Vertical motion really is throws. Is that high? Yeah, but it's also like getting thrown, so it has a higher dimension.
What do you say? A. Okay. It would be just like the same question is like, if I drop these, which one's going to hit the ground first? Huh, that's funny. The one that was closer to the ground. Okay, like that's the same question as this. Because I threw it horizontally, it doesn't matter. Vertically, they both start at rest. Okay, with that, they're independent. Are we getting this? Am I beating this into your brain? They're independent of each other. I don't care if it's going horizontal. It started at rest vertically. Okay? All right, so. Feel that? This is crazy. I wrote a huge grant for that. That was so much. Put this in. I was so thankful they put this anti-gravity button in. All right. So when I roll this bowling ball off the table, how's it going to move? Same. Why? There's no forces. Act on it. It's going to do exactly what inertia wants to do. Which, how would you describe same? More detail than same.
Stays in motion.
Stays in motion at a constant velocity. Okay, I'm gonna turn gravity back on because I'm getting a little nauseous. I don't know about you guys. Man, that was so great. Only in physics.
Bro, why are you so bad?
Okay, so, we just get, we're gonna roll it again. Okay, so we roll it again with gravity on. Okay, were there any, were there any forces acting on it horizontally? Any forces acting on it horizontally after I pushed it? No. So it did exactly what its inertia wants to do in the horizontal direction, because horizontal motion is independent of vertical. Give that one a shot. Thumbs up when you have a guess. Hold on, wait for it. Hold. Now talk to your neighbor. Tell them why.
Because it's not, it's going down, it's not affecting the force. It's going down, so it doesn't affect, it's like going down vertical, so it doesn't affect the horizontal velocity.
Correct answer is A. Why?
It's going down vertical, so it doesn't affect the horizontal velocity.
What is it is vertical?
The car.
I'm going to say, what's going on vertically? Gravity, the force of gravity causing acceleration. But in the horizontal direction, are there any forces acting on it horizontally? No. So it's going to do exactly what its inertia wants to do, which is moving at the same speed it had right here. Okay with that? There's nothing acting on it in the horizontal direction. It's just like, yes, I love going at this constant velocity. Okay? So, if I could roll this bowling ball, I'm making up some numbers here. 3 meters per second, let's say. Going at 3 meters per second. Gravity is off. Okay? If I turn gravity on, it falls. But it still maintains that 3 meters per second the entire time. Just as if gravity was off. Because it's independent. Gravity is acting vertically. Okay? Now, in the vertical direction, if I drop something, it starts at rest, and then in the vertical direction, how would you describe its motion? Experiencing the acceleration of free fall, yes? You okay with that? Okay. If I shot something horizontally in the vertical direction, it behaves just like the one I dropped. Is no difference. Identical. You okay with that? So this ball is moving horizontally simultaneously as it's experienced acceleration vertically. Okay? They're independent of each other, but they're combined together. Now, the only thing that I can do differently now is, let's just pretend, just for convenience sake, this is going 4 meters per second here. If the ball had a speedometer on it, how fast would that speedometer read? What would the resultant velocity of the bowling ball be at that moment in time? Well, if we do head to tail and then do Pythagorean theorem, we'd find that would be going 5 meters per second. So I don't know if this dawned on you, but everything you've learned thus far in this class, boom. Constant velocity, unit 1, free fall, unit 2, vector addition, what we're in right now. Okay?
So velocity is constant on the horizontal this time, and gravity is just there.
Yep. Okay? Thumbs up when you have a guess. Tell your neighbor. What do you think? Tell them why.
Yeah.
Velocities in each not easier because it's the water. The water is stop. Not stop. Yeah. Oh.
Correct answer is? Correct answer is only B. If it's one of these two, is it in free fall? If it's in one of these two, that's where the car's in the water, not in free fall. B is the correct answer. You okay with that? It is moving, but it's moving horizontally, not vertically. Okay? All right, example problem. Ooh, buddy. If a ball is thrown 6 meters a second horizontally from a 10-meter tower, how far away from the base of the tower will it hit the ground? First step, draw a picture. That. Okay. Pick your initial and your final positions. Okay. Please do not fight me on this one. Make a chart. Horizontal variables, vertical variables. Just like we had a list of variables for the bear and a list of variables for the tourist. We're gonna have a list of variables for the horizontal direction, a list of variables for the vertical direction. Okay? Tell me what variables we know. Let's just start horizontally. What variables can we put up there horizontally?
6 meters per second.
Okay, 6 meters a second, and what variable do we give that? That is what type of measurement?
Velocity.
Velocity, okay? We could say initial. What is our final? Also 6. You okay with that? What is our horizontal acceleration? 0. Okay, and we're looking for horizontal displacement. You right with that? Okay. In the vertical direction, what do I know?
Equals 0.
What is equal to 0?
The initial.
The I
Good. Initial vertical velocity is equal to 0. That's your catchphrase. Something to launch kick horizontally, then you know your initial vertical velocity is 0. What else do we know in the vertical direction?
It's in free fall, so it's negative 9.8.
Vertical acceleration is negative 9.8 meters per second squared. And delta y is equal to, watch yourself, negative 10 meters. Why is it negative?
Because it's going downwards.
It's going downwards. Okay, how are we doing on our setup? Okay, do we understand why we're setting it up in this chart fashion? They're independent. Do not take numbers from this side and numbers from this side and put them in one equation. That is instantaneous death. Okay? They're independent of each other. That's why we did this. Don't mix them up again. Okay? Now, when we're looking at this, you're like, probably should have put the kinematic equations up here. You're looking at this like, wait a minute. I recognize something. Don't write this down. I recognize something. Hey. Boom. Look at that. I've got it all. Don't write that down. I'm going to erase it. Or you can just say, don't use. Okay. That just killed that whole expression by multiplying by 0, including our unknown. And what we end up with is 6 squared equals 36. Huh. Yep. That's true. Not helpful. Okay? That's not the route. I'm like, dogs, man, I thought I was there. Now, check this out. Time. We don't know that. But time is the variable that is not constrained vertical or horizontal. Time is just ticking away. Okay? Time is the measurement that bridges the gap between horizontal motion and vertical motion. It's moving both horizontally and vertically at the same time. Okay? So could we solve for time with the vertical? If you have your kinematic equations, you'd be like, oh yeah, check this out. But I'm going to tweak it just a tad bit. I'm going to modify that to delta y, little y subscripts just to I didn't change the equation, I'm just trying to communicate. Okay? So I've got negative 10 meters is equal to initial vertical velocity is 0, so that knocks that guy out. 1/2 times negative 9.8 delta t squared, negative 10 over negative 4.9 is equal to t squared. Delta t is equal to 1.43 seconds. See how the negative signs get knocked out? Make it legal to take the square root. Okay. Then what can we do?
Wait. Negative 10 divided by negative 4.9.
And then
That's about over, that's over 2.
Right, then you
Square
take
that
this-
and yeah.
square root. Okay. What can we do? What can we do with this number? Or, okay. So we can take this number and bring it. We can apply that time to the horizontal direction. Okay. Now, when can we use this equation? When velocity is constant. In the horizontal direction, is velocity constant?
Yes.
Yes. You can use this equation or you can use a kinematic equation, it's fine. You just need to incorporate time. So you're taking, personally I like that one. It's just easier, but whatever. 6 meters per second is equal to delta x over 1.43 seconds. And when you put that in there, you find that to be 8 point something or other. 8.57 meters. Okay? Is that in the realm of possibilities?
Yes.
Sure. 10 meters, 8.5, yeah, sounds good. You see how we did that? Separate them. Horizontal motion is independent and vertical, okay? Time is the thing that connects the two. It's a lot of work, I get it. But if you're organized, it'll go well for you. Okay?
So 857 meters.
Good?
That is kind of tough.
Okay, so this is how you bake a projectile motion problem. This is like the recipe. It's on your notes. I just took you through it. Okay. All right. Check this out. I have this part that has a cool contraption.
I'll be
Okay. When it passes this post, it launches the ball straight up. Okay, so my question is, if I push this, what's the ball gonna do? Think, half, think, bring, think, think. Everybody have a hypothesis? Here we go, ready?
It will remain at the same speed of horizontal velocity. but
Okay.
gravity will-
Why? Tell your neighbor why it was caught. Tell your neighbor why it was caught. Here we go again, ready?
It decided to go away. It Uno reversed the pass.
Okay? Now, I don't know why this makes it look so much cooler, but it does.
Yes.
Boom. Woo! Good
Yes.
time.
It's like one of those weird magic things.
Okay. So, how would you describe the motion in the horizontal direction? Constant velocity. Why? Because no horizontal forces. It did what inertia wanted to do. Okay, in the vertical direction, how would you describe its motion? What happened vertically? Have constant acceleration. Yes? Free fall. Because of the force of gravity.
Because of gravity.
Okay, good with that? So, in the horizontal direction, it was going 2 meters per second, making that number up. It maintains that 2 meters per second the entire time. Because there's nothing else acting on it. It's doing exactly what inertia wants to do. It's like, yes!
Keep going.
But in the vertical direction, starts out, slows down. How fast is it going to the highest point?
0.
Is it moving overall at the highest point? Yes, it's moving horizontally, but vertically, 0. And then it speeds back up. Good with that? Okay. If the takeaway as you walk out the door, do you know how to calculate things moving at a constant velocity? Unit 1. Do you know how to calculate things in free fall? Unit 2. If you know how to calculate this, and you know how to calculate this, then you know how to calculate this. Because this is just a combination of this and this happening simultaneously. Good at that? You are now empowered to do the worksheet that's due tomorrow. Here's the demonstration that you didn't see.
Worksheet you checked yesterday.
Yes, sir.
Have that too.
Yep.
I was also gonna ask if I could see my test score.
Yep. I'll record this and then. There you go. Here's the demonstration.